I'm a former JPL scientist, and I'm going to tell you why NASA's $30 billion 79 launch moon-based plan isn't just a pipe dream. It's a roadmap that could have a permanent habitat on the lunar South Pole by 2036. After Artemis II's spectacular lunar flyby, NASA unveiled a new strategy they call ignition. Think of it as a 10-year sprint to turn the moon into a real-world space station. Here's the four-phase timeline. 2028, the first crew lands. 2030, a permanent habitat starts taking shape. 2032, 6-month crew rotation cadence begins. And in 2036, a compact 20-kilowatt nuclear reactor powers the whole settlement. All of this culminates in Artemis 18 in 2039, the first true colony mission. To make this happen, NASA needs 79 launches. That's 73 landers, 10 rugged moon buggies, 12 small hopper drones that hop between craters, 4 habitat modules, and a 20-kilowatt nuclear reactor that fits inside a single launch canister. The South Pole is a golden kitchen for a base. The rims of a few crater walls stay in near constant sunlight, perfect for solar panels, but inside those rims are cold traps, deep, eternally dark pits that hoard water ice, the raw material for life support and fuel. NASA isn't doing this alone. SpaceX will adapt its Starship upper stage into a lunar lander called the HLS, or the Human Landing System. Blue Origin is polishing an upgraded Mark I lander called Blue Moon, with plans to test that lander later this year with a lunar touchdown, and then next year it will deliver NASA's Viper robotic rover to the lunar surface. NASA's mantra, whichever lander gets to the moon first, we'll use. The race is on. Instead of building new habitats from scratch, NASA is salvaging the 2 aluminum shells built for the now cancelled Lunar Gateway. They could be turned into the first 2 rooms on the lunar surface. Surprisingly, these modules are already showing some signs of corrosion before they've even been delivered, but the teams believe that this can be fixed. Here are some of the vast challenges that would need to be overcome before NASA can realize the dream of a permanent lunar base. Lunar dust is the real villain. It is razor-sharp, electrostatically charged, and sticks to everything. Suits, optics, seals. In the low-gravity environment, it never settles, forming a permanent fog. It's really nasty to breathe, and Apollo astronauts reported eye irritation from it, so we know that is a problem that needs solving. With only 1/6 Earth gravity, rovers on the moon can lose traction. NASA is designing dual scoop rovers that push forward and pull back to try and overcome the traction issue. On top of that, there's no GPS system on the moon, so NASA needs to develop a navigational system that replaces a compass with GPS signals beamed from Earth. The harsh vacuum means Earth-based lubricants evaporate and metal parts corrode from microparticle impact and from the radiation from the reactor. NASA's qualifying radiation-hardened cabling and lithium-based thermal control panels. All of this is baked into a pretty optimistic $30 billion 11-year budget. It's backed by a 2025 executive order that instructs NASA to prioritize the moon over Mars. Critics say the schedule is optimistic, especially the 2028 crew landing. Any delay in SpaceX's Starship or Blue Origin's lander could push everything back. So why bother with a permanent base on the moon? A permanent base will let us harvest water ice and test in situ resource utilization. It will force us to solve a range of technical challenges and give us a stepping stone to Mars. It will also give us huge new science opportunities, from in-depth lunar exploration to the potential for radio astronomy on the lunar far side, shielded from the radio frequency interference of Earth. It also opens a new frontier for international cooperation through the Artemis Accords and possible commercial opportunities, think lunar mining, tourism, and research labs that never have to come back to Earth. The bottom line, NASA's ignition plan is a massive, tightly choreographed ballet of rockets, landers, private partners, and a nuclear heart, all aimed at turning the moon's South Pole into the first off-world village by 2036. Will NASA establish its moon base by 2036, or is this actually all just a pipe dream with too many technical hurdles? Let me know what you think in the comments. All of this starts with people who are curious enough to watch videos like this, ask questions, and support science. If that's you, and since you got this far in the video, it seems like it must be, why not come and join me live on Twitch to chat about the moon and everything else space and astronomy related. I'm live Tuesdays, Thursdays, and Sundays at 6 p.m. Pacific and Wednesdays at 6 a.m. Pacific. I hope to catch you there. Until then, smash the like button, subscribe, and ring that bell so you never miss a space science update.